Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. Today we're talking about a historic launch milestone in Florida, a major roundup of news from China's ambitious space program, and some big upgrades from Blue Origin.
Plus, we'll dive into a new AI tool that could revolutionize the search for life on Mars. And we'll revisit the moon's dramatic origin story with some fascinating new research. Let's get started. First up, a truly staggering achievement from Florida Space Coast. This week, a SpaceX Falcon 9 rocket is set to become the 100th launch from the Cape Canaveral and Kennedy Space Center area in a single year.
100 launches. It's a number that would have been pure science fiction just a decade ago. To put it in perspective, the Space Coast saw 31 launches in all of 2021. In 2022, that number nearly doubled to 57, and now we're at 100.
It's a testament to the incredible success and efficiency of reusable rocket technology, which SpaceX has pioneered. Being able to refly these first-stage boosters again and again has completely changed the economics and the cadence of spaceflight.
Absolutely. And this milestone launch isn't just symbolic. The Falcon 9 is carrying another batch of 29 Starlink satellites, continuing to build out that massive internet constellation. It's routine, yet revolutionary at the same time.
A perfect example of the new normal in space access. It's an amazing milestone for the entire industry.
Speaking of bustling space programs, let's turn our attention to China, where there's a flurry of activity and some unexpected developments. We've got 4 big updates.
All right, let's break it down.
First, of course, is the drama with their Shenzhou spacecraft. An uncrewed Shenzhou is launching in a few days, but it's a replacement for a previous one that was damaged. As we reported earlier this week, the crew of Shenzhou 20, who were on the Tiangong space station, had to return to Earth in a different spacecraft.
For listeners who missed the earlier stories, can you give us a quick recap?
The report says there was a crack in a window of their original return module. That is a serious issue, and it's a stark reminder of how unforgiving space can be. Thankfully, they had a backup ready to go with the arrival of the Shenzhou 21 crew and, more importantly, spacecraft. Hence the need for the Shenzhou 22 to get there ASAP as an uncrewed mission.
Wow, that's a close call. Glad the crew is safe. What's the next update?
On a more positive note for the Tiangong station, it's set to host its first international astronaut in 2026. This is a major step for China's goal of making Tiangong a hub for international cooperation, much like the ISS.
That's a significant diplomatic and scientific milestone.
It is. However, the third piece of news shows it's not all smooth sailing. Many of China's commercial launch companies, which are trying to emulate SpaceX's success, are seeing significant delays with their maiden flights. It highlights just how difficult developing reliable rockets really is.
Right, it's not as simple as just copying a design. There are immense engineering challenges.
Exactly. And finally, perhaps the most scientifically intriguing story from China, the analysis of the Chang'e 6 lunar samples, brought back from the far side of the moon, has revealed signs of rust.
Rust on the moon. But rust requires oxygen and water. How is that possible in a vacuum?
That's the big question. Scientists think that oxygen might be delivered from Earth's upper atmosphere via the solar wind when the moon passes through Earth's magnetotail, and the water could come from micrometeorite impacts. It suggests the moon's surface chemistry is far more complex and has unexpected oxidizing conditions. A very cool puzzle.
From one ambitious program to another, let's talk about Blue Origin. Jeff Bezos' company is making some major upgrades to its heavy-lift rocket, New Glenn.
New Glenn has been in development for a while. What's new?
They're focusing on enhancing 3 key areas: propulsion, structures, and reusability. This involves tweaks to their powerful BE-4 engines and improvements to the rocket's overall design to make it more robust for repeated flights. But the biggest news is what they're building next.
Oh?
They are planning a super heavy version called New Glenn 9x4. This beast of a rocket is designed to lift an incredible 70 metric tons to low Earth orbit.
70 metric tons. That's huge. That puts it in direct competition with SpaceX's Starship and NASA's Space Launch System.
Exactly. It signals that Blue Origin isn't just aiming to compete in the current market. They're aiming for the future of large-scale space infrastructure, missions to the moon, Mars, and beyond. It's a bold move.
From the colossal scale of super heavy rockets, we now go to the microscopic in the search for life on Mars. Scientists have developed a new AI tool called Life Tracer.
I saw this. The approach is fascinating. For decades, our search for life has been about looking for specific biomarkers, certain molecules that we associate with life on Earth. But Life Tracer does something different.
It does. Instead of hunting for individual molecules, it analyzes the entire chemical inventory of a sample. It uses machine learning to look for patterns of complexity and diversity in the molecules present. The underlying idea is that life, as a process, creates much more varied and complex chemical signatures than non-living geology.
So it's not looking for a needle in a haystack. It's looking at the entire haystack and saying, does this haystack look like it was made by something alive?
That's a great way to put it. And the results are promising. In tests on terrestrial samples, it has an accuracy of over 87% in distinguishing between samples with a biological origin and those with a non-biological origin.
That's incredibly powerful. It could help us analyze data from the Perseverance rover samples without the bias of only looking for Earth-like life. It could detect life that's truly alien.
And a very positive use of modern AI technology.
For our final story, we journey billions of years into the past to uncover a new clue in the mystery of how our moon was formed.
The giant impact hypothesis. The theory that a Mars-sized object, which we call Theia, slammed into the proto-Earth, and the debris from that collision eventually formed the moon.
Exactly. But a key question has always been, where did Theia come from? New research suggests it wasn't some rogue planet from the outer solar system that wandered in. It may have been a close neighbor of early Earth.
A neighbor? How could they possibly know that?
It comes down to chemistry, specifically isotopes. You see, the chemical composition of planets varies depending on where in the solar system they formed. By meticulously analyzing isotopes of elements like oxygen in rocks from both Earth and the moon, scientists can work backwards.
Right, because the moon is made of material from both the early Earth and Theia.
Precisely. The isotopic signatures in lunar rocks are remarkably similar to Earth's. This new analysis suggests this is because Theia itself formed in the inner solar system, in a very similar orbit to Earth. It was, for all intents and purposes, Earth's planetary sibling.
So this colossal moon-forming impact wasn't an attack from a stranger, but a collision between neighbors. It paints a picture of the early solar system as an even more chaotic and crowded place than we imagined.
A cosmic fender bender that gave us our beautiful moon.
And that's all the time we have for today. From a historic 100th launch and rust on the moon to super heavy rockets and new insights into our own cosmic origins.
The universe is never short on stories. Thanks for joining us on Astronomy Daily. I'm Avery.
And I'm Anna. Until next time, keep looking up.